In trading, knowledge is power, and lack of knowledge in what you're doing can be costly, very costly. So you need a solid foundation of quality market education. Whether you're new to trading or a seasoned veteran looking to add advanced strategies to your arsenal, there's always something to learn and something to improve on. And now you can access the same knowledge that professional traders receive with Market Rebellion's Trading Education. I'm Bill Johnson, Head of Options Education here at Market Rebellion, and we've assembled a comprehensive curriculum based on decades of real trading experience, covering everything you need to know about trading options from beginner to advanced. We go way beyond the nuts and bolts of options theory to teach you how to apply specific trading strategies and the techniques needed to adapt your trades when markets shift. Regardless of your goals, you'll gain access to the education you need with easy-to-consume lessons so you can learn to trade with confidence, enhance your knowledge, and master the practical skills required for market success. So please join us for in-depth trading education only from Market Rebellion. Hey, welcome back to all of our market rebels and another exciting day in the markets too.
Hey.
And another time for Coach's Corner. So for everybody who's new,
let's do it.
Let's do it. So if you're new, it's great having you here. What we like to do is to showcase our world-class coaches. Stu is with us every time. Every once in a while, we're able to bring Scott Thorstensen in. But we just like to bring you topics in options, strategies, pricing that you're probably not going to hear anywhere else. And they're going to be critical for making good decisions and trading decisions. And today, Stu, we've got a very cool topic because I know you get this a lot from students talking about Theta. They'll either talk about the benefits of Theta for a short position or the negative effects for a long position, which you know is really kind of a misperception, but they don't know where the numbers are coming from or even how to calculate it.
I don't think there's any newer person out there that thinks that having to pay Theta is a good thing.
Exactly.
Very bizarre. The whole concept is just like, let me collect. Let me collect
and collect. Yeah. So whether you want to collect or whether you're willing to pay on the long side, we want to show you some good little reference points and even a way to calculate Theta. It's not so much that we expect people to pull out a calculator and start knocking out calculations, but we want to show you where these numbers are coming from. And if you have a pretty good idea of where Theta is today, we'll show you'll have a very good idea where it's going to be when 25% of the time remains, and you can kind of figure out where it's going to be somewhere to the left or right of that time frame.
Yeah, or halfway or anywhere, really.
Yeah, it can give you at least a perspective. You don't have to go to a pricing model to understand how this works. So let's get started. We're going to start off with a chalk talk, our little thought-provoking question here, which we will answer at the end, and hopefully you'll be able to answer it as well. But here we go, Stu.
And the idea here, everyone, is for you to have an idea of what if I do a strategy, what's it going to look like down the road? We talk about this all the time. Yeah. What's it going to look like down the road without having to guess, without having to open
or
up
be surprised.
Your platform to see where it's going to be. Hey, if the stock, these are derivatives. If the stock does this X amount of time with this implied volatility, what's it going to look like down there? That's what you need to be able to ascertain to help you make a decent decision about what strategy you're going to use.
Absolutely. So let's take a look at an example here. We're going to assume we've got a $100 call trading for 4, and our option has 90 days to expiration. And the question I'm going to ask for people is going to seem kind of odd because most people would say, how would you ever figure it out? You got to go to your platform. But I'm going to ask you, what's the options Theta? Now, I can look at this and tell pretty much immediately what the Theta is going to be right now. And if you're not able to do that and to figure out these points in time, kind of reference points, you're behind the 8 ball because now you're having to say, I have no idea where these numbers come from. They just look like magical numbers pulled out of the air. Well, there's a reason that they're there. And you need to understand or at least have an inkling of an idea where they're coming from. So what we're going to talk about today, Stu, is how fast does an option decay? And where are these numbers coming from? If half the time is gone, how much can you expect to lose on your option? If 75% of the time is gone, how much should you expect, and on down the line? So if that seems kind of weird to you of how somebody could look at that and figure that out, we're going to show you how to do it right now. Now, to kick things off,
I'm gonna throw one thing in here, and I kind of figured you were going to be talking about at the money options. Just a little side note, and we're most likely not going to cover it today. Just another kind of an offshoot of this topic. Keep in mind, everyone, that there are different curves for at the money options.
Oh yeah,
and out of the money options.
And in the money.
What we're talking about here, I think, according to this slide, which I figured Bill was going to do, was at the money options.
Yeah. All of these little tricks I'm going to show you, they're not really tricks, but they're just showing you the inner workings of the calculations, are all for at the monies. And so we're going to assume that we're dealing with at the money options. We're also going to assume that interest rates are zero. And even though that's not true in today's world, although after yesterday's Fed announcement, who knows, we're going to be heading back down there again. But they're not going to make a significant part most of the time. So we have to say,
probably,
right?
Unless you're talking about long periods of time with lots of money in the
very
option.
expensive expiration or very expensive strike
think about
prices.
a car loan. If you have a car loan for $1,000 or $2,000 for a week or 2 weeks or a month, it's nothing. Doesn't really matter what the interest rate is. But if it's 10 years or 8 years and it's a couple hundred
Tesla, right, or a Ferrari, now we're talking major
an
major money.
F430, an F what is it, the 430 or the 360 Modena? If you're buying the Ferrari, it's going to mean something. So just keep in mind that, for what Bill is doing here, what we are doing, it's immaterial, the interest. So that's why we're making it easy by taking out the interest.
We could do it. We'd have to do a second calculation and add it on to this. But again, we're just trying to show you reference points.
Yeah, it's just an interest rate calculation. It's not hard.
So here we go. We're going to start off with a question. We've got the $100 call trading for $10.
Okay.
And you see that the theta on your platform is going to show with a minus sign. And let's say it shows minus 0.05. Yeah. And the reason it shows as a negative is that for long options, that's usually what your platforms are assuming, is that it's a long option. It's going to lose 5 cents.
Bill, but I got a question. Why does the platform always assume it's a long option?
Well, I think you got to assume something. Why do they assume the stock is long? They're just showing you
why don't they assume it's a short option and make it a positive number?
I think most people, you could. I just think the calculations are easier to say from the long position. If you want to flip it, you can certainly do it.
Oh, man. Pretty funny. Okay.
But, the theta, let's say, shows minus 0.05. Now, the question that I have for you, does this mean that you're going to lose 5 cents every single day? And we get this all the time from traders, and many of you out there are probably already nodding your head. Yes, they'll say, I'm going to lose 5 cents per day.
Every day.
Every single day between now and
the question is assuming for the life of the option.
And what we're going to show you, if you really think about it, just in case somebody has convinced you that's exactly what it means, you're going to find out that the math doesn't add up.
No.
So, for example, remember we've got the 100 call trading for 10, 100 days to expiration. Now, if you lose 5 cents per day, that's our assumption. The call is going to lose $5 over 100 days. And that means the call is going to be worth $5 at expiration, but it should be zero. So that's not adding up.
However, lot of principles going on here, people.
Something's going on, right? It can't be 5 cents in each and every day. Now, we can look at it in a different light. If we say, all right, our assumption is that it's got to be worthless at expiration, which we know is true, assuming it's still at the money, we can take our $10 price divided by that 5 cent theta, and therefore it's going to take 200 days to expire. But right here it says 100. It should be 100.
Yeah, that doesn't work.
So that doesn't work. So if you notice here, there's an interesting connection that if we assume that the option is 10 right now, under this assumption, it only goes to half its value. But if we go under this assumption that it's got to be worthless at expiration, it goes to twice as long.
Now, hold on 1 second. There might be people, especially if you're a little bit newer at the game, who are thinking, well, if that's the case, it might actually be $5 at expiration. I mean, that might be a conclusion that you come up with, and I can tell you that you're going to be wrong.
Right. Yeah, it's going to be 0 at expiration. Remember, we're talking about at-the-money options. So what we're just trying to show here is that it cannot be true that the option loses whatever that theta number is each and every day between today and expiration. It can't. It's got to decay at some point faster, because we've got to either A, bleed off this additional $5, or get there before 200 days, right? We got to get there in 100 days. So at some point, we got to be faster than 5 cents per day. All right, so how can we look at this and figure out what our theta is, what it will be at various points in time? And before we show you that, as always, let's take a quick look at our little plug here for marketrebellion.com/get started. Free website, free landing page right there, lots of great articles and videos to help you get started with topics very much like this. Okay, and I can't emphasize that enough. There's so much tremendously bad information on the web, as there is with everything, but especially for options. And if you're looking to get into options trading, investing, anything, you really need to get on a strong footing. So give that a shot. It's all free stuff. It'll put you on the right path. So let's start with theta. All right, theta is our Greek that we use to measure various changes with our options, and it shows the rate of change from one day to the next. That's really what it's showing. Now, technically, it should be for much shorter periods of time. And if you want to get really technical, fractions of a second. That's when theta becomes dead on accurate. But I mean, really, technically speaking, a day is really too long. But for practical purposes, close enough. Going to get it.
We have to use something. We're not going to use something, right? We're not going to use it an hour, and a week doesn't really work. So
right,
we pick a day. That's it. I'm
going to say it's a day, and it will get you reasonably close, assuming everything else stays the same. So, for example, if we have 100,
but that's a really important point, Bill, because a lot of people I find think like, okay, well, it's the clock's going to flip overnight, or
right,
or is it going to be different in the morning, or is it what is it? They can't get the timeline down, and like Bill says, the answer is it's going on all the time.
All the time.
All the time. Through the night. It doesn't
stop on Friday and pick back up on Monday. It's always going.
Yeah.
Now, it might not register. You might not see it.
No, you won't see it.
But as long as time is moving, trust me, it's affecting the expiration date of that option.
Absolutely.
Now, another thing, too, since we're on that point, you might say, oh, my option's going to lose 5 cents per day. And at the end of the day, it's lost $1. Well, that's probably because the stock moved. Could also be because volatility dropped, or both. Yeah. Mm-hmm. But so in the real world, it's going to be extremely, extremely rare that you're going to see your option lose theta by the end of the day, exactly theta. It's just to show if everything stayed the same, mostly stock price and volatility, this is what you could expect to lose just from the passage of time.
This is a little bit about what we talked about last week.
Yeah, it is.
We're talking about, I think it was last week, wasn't it, Bill? Like, where's the money? Where'd the money come from?
Yes. Yeah. Right.
It came from
Where do
Delta,
the profits come from?
Like Bill just said, right? Maybe it came from Theta. Maybe it came from both. Yep. Maybe it came from a little bit of IV, right? You have to know that. Yep. You have to be able to say, well, where's the money? What do I expect? Where's the money? What's going wrong here? What's working? Both of them, right? If it's working, you kind of want to know it's working. Want to know where the money is coming from. So you may want to take action to cash out a little bit in some fashion.
Right.
If it's not working, you may want to cut your losses if something isn't working. Maybe vol's not working, right? But you got to know that. You got to know where the money's coming from.
Yep. So let's say that we put this into a pricing model, and it says that with 100 days to expiration, the option's worth 10. Now, if we go to that same pricing model and we make it 99 days to expiration, we just take 1 day off the clock, the pricing model might show that it's worth $9.95. So what the pricing model is doing when it calculates theta, it's just saying what will be the difference between these two prices. And in this example, it's lost 5 cents. So your platform's going to show you minus 0.05. It's just telling you that if another way to think of it, if you go to the pricing model and knock one day off, that's how much the option's going to lose.
And again, it's assuming it's a minus because it's assuming it's a long option. The real deal is it's a nickel. Whether you're long the option or short the option will determine whether you're losing value on a long or gaining value on a short. But the answer is it's a nickel, and that's what we're focusing on here.
Yep. So the thing that people forget is that now you're going to get a new theta. It's going to be a little bit bigger. Or I should say, I know for all the math people who say, wait a minute, that's smaller. Let's say forgetting about the minus sign. You're going to go from maybe 0.05 to 0.051. You're going to decay a little bit more, and then maybe 0.052. But it's going to always increase. Again, not necessarily drastically. Might be, but it might not be drastic, but it's always going to increase at least a little bit. You're going to get a new delta, a new gamma, a new theta, new vega. And so you have to realize that's why it's another reason to show why it's completely incorrect to say that you're going to lose 5 cents each and every day.
And as a little sidebar, that theta number will also change, can also change, I should say, as implied volatility changes as well.
Oh, big for sure. Yep.
Right? Because it's just really affecting the value of the option. Yep. And what theta is doing is it's just taking into account the decay of something.
That's why I have to say all things being equal. I always tell traders, as things change, all of your Greeks change. So everything, at a minimum, time's changing, but technically your stock is probably not exactly to the penny where it was. Volatility might be up or down a few small ticks. It's not always going to be the same. So that's why you have to put it in a vacuum and say, let's leave everything else fixed. We're just going to knock one day off the clock.
Right.
All right. So that's where our theta is coming from. That's the concept of it. But to really understand what it is and where it's coming from and how to calculate it, which we're going to show you, you've got to understand a little bit about option pricing. So we're going to take
Bill. I'm the first one there. I'm the guy with the smallest brain in there. You're the guy in the middle.
That is definitely not true, I can assure you. So now let's take a little sidestep here and talk about, which we've done before, the square root pricing rule. Now, yes, I hate talking about square roots because I know it scares people to death. We have no choice. Theta is a mathematical concept. And so we really have no way, if you're going to talk about where the numbers come from, but to talk about this. But it's not real hard. So here's the idea. It takes 4 times the amount of time to double an option's price, again, assuming it's at the money. And the reason for this is that option prices are proportional to volatility, and volatility is proportional to the square root of time. That's where that's coming from. So here's what it means. I know it sounds complicated, but here's what it means.
Yeah.
We have a 1-month option trading for $1.
Mm-hmm.
All right. If you don't believe it, you can go into a pricing model, try this at home, make a 1-month option trading for $1. Now, make it a 4-month option. And most people think, well, it should be $4 because you've got 4 times the amount of time. And that's not true. That's where a mistake is made. So what's going to happen is we have to say, all right, we have 4 times the amount of time, right? We're just going to divide the number of days to expiration in the second option by the first. And we're going to come up with a number. I made it nice and round, so we get a nice round number of 4. We take the square root of that, punch 4 into a calculator, square root, you're going to come up with 2. We're going to take this number 2 in green, and that's what determines our multiple on this side. So notice that it's not going to be worth 4. It's going to be 2 times the value of the first, which means it's going to be $2.
$2, right? So what's Bill saying here?
Twofold.
1 month is $1. 4 months is $2. 4 times the time, twice the money.
Exactly.
Right. Now ask yourself, well, which one's a cheaper option? Right. That's a good question to ask yourself. Which one's a cheaper option? You can
depends on how you look at it.
Option and do it 4 times and spend $4. Or you could take a 4-month option and do it once and make it $2.
Yep. But you still have to spend twice as much.
Twice as much.
This is where strategies come in. Sometimes it will be better to pay the $1 for this.
Now, again, real sidebar here again. This is also, like Bill keeps saying, this is assuming a straight line volatility. This is assuming that we don't really have any changes.
All things being equal.
That's right. There's no tilt in the vol curve.
Right. Anytime we talk about anything in options, we just try not to keep repeating it, but it's all things being equal. Everything else held constant. So you might go in the real world and look at a 1 month option trading for $1 and see this one's at $2.30 and say, hey, wait a minute, that's wrong. No, the math isn't wrong. There's just a tilt going on.
Right. Or 170 could go the other way.
Could go the other way. Right.
Could be an upside tilt, could be a downside tilt. Yep.
So anyway, the point is that the second option has to be 2 times that of the first. If this first one was trading for $6, this would be $12, all things being equal. So the thing to note right now, and this is going to be important going forward, it takes 4 times the time, or if you have 4 times the time, you take the square root of 4, which is 2, we're going to get 2 times the price.
Yeah.
We can also work it backwards. I could say if you have a quarter of the time, or 0.25 times the time, we take the square root of 0.25 and we get, look at that, 0.5. We get half the price. And we can see that going in this direction. We go from 2 to 1. And that's because the 1 month option has a quarter of the time, and therefore its price must be half the price.
Right. Don't get lost in all this noise, people.
It's just
the same equation. You just go in the back
question
door.
whether you're going forward or backwards, right?
Yeah.
It's the same idea. So we're just going to take how much time remains on the option, and we're going to take the square root of that. It's just a small step. So for example, let's say that the 100 call is trading for 10, days to expiration are 100, and the question that we have, what's the call worth when 25 days remain?
25%.
Now, I've highlighted this word remain because sometimes when I'm teaching this to traders, they'll say, oh, well, 75% of the time has gone by, which is true, but the pricing model is always pricing based on what remains. So you don't want to use 75%, you want to use 25%. All right, so when 25 days remain, that's going to be 25% in this example, we're going to use 0.25. Just as we saw in the previous slide, we're going to take the square root of that, which is going to be 0.5. And what that means is that 50% of the option's price remains. And that tells us that our $10 option up here must be 50% of 10, or trading for 5. So think about that. It does require 75% of that time to pass before the option loses half of its value.
Or 20 with 25 days left.
It's still going to be worth half the price.
It's half the price.
Yep. So if we look at our time decay curve, now this is a curve that most people see. This is what's usually shown in books and on websites. As Stu mentioned, you got to be very careful. We get this a lot of times. New traders will say, well, this is what my time decay curve looks like. No, this is what your time decay curve looks like for at the money options. If you're in the money or out of the money, it's going to be curved the opposite direction this way.
Yeah.
But again, just to make the point, we're going to stick with at the money options. So let's go to 25% of the time remaining. Right there is 25%. What's our calculation, everyone? Square root of 0.25 equals a half. And look at that. Look at where that's lining up. It's lining up at exactly 5 when we started up here at 10. Right? That's not contrived. This is right out of a pricing model.
So think of this from the starting line. 3/4 of the way in, my option is going to be $5. What do I want to do? Right? Think about that. Now you got a lot of information.
Yep. So we're going to lose 75% of that time is going to go by, or 25% of the time remains for us to lose half the value. So the thing to remember, a good reference point, when 25% of the time remains, 50% of the option's price remains. That's why I've highlighted that word remains. It's a good little mnemonic. It's always about how much is left, not how much we lost. All right, so everybody see the pattern there. Now with that, we're going to be armed with some very powerful tools. Before we get into those, one more quick look at marketrebellion.com/get started. Find all kinds of great videos and articles to help you with your options careers. All right, let's try a different one here, Stu. What is the options price if 50% of the time remains? All right, so now as an options trader, you can just kind of whip this out on your calculator and you'll say, all right, well, here's my time decay curve. We're starting at 10. Where's the halfway point? Right there. That's 50%. We take the square root of a half and it just turns out to be about 0.71. So we know that the options price here will be 71% of the starting point. It's going to be $10 times 0.71 or $7.10. All right. It's not going to be $5, even though half the time remains or half the time is gone.
Yeah.
All
And
right, so you can,
we would just call it $7.
exactly. After bid-ask spreads and everything else, it's just a good reference point.
Yeah.
But one thing that you'll start to know as you start working with square roots, you'll say, all right, I know that the halfway point is 0.71.
Right. And think of it backwards. Well, I have a $10 option with half the time remaining. It's still going to be a $7 option.
Yeah.
It's pretty good.
Yeah, exactly. It's just a reference point. That's all it is.
Yeah.
So let's do another one. So remember here that 50% of the time remains, or if 50% remains, 71% of the options price remains. That's another good little kind of a reference point. You don't need to know every point along the curve.
No.
But if I can figure this out, I can at least kind of get some ballparks in here of what it's going to do.
You want to get a feel for how this curve kind of lives, right?
Exactly.
Like operates.
Exactly.
Yeah.
All right. So that's how we can figure out the prices. Now, think about this. If we can back into what the options prices should be, shouldn't we be able to figure out what the theta should be? It's the same problem and just in disguise. So let's turn the page here and say, what's the options theta? Something that most traders will say, well, you got to go to a pricing model for that. No, you don't. You don't. So watch this. Here's our time decay curve. Our option starts at $10. We can do, if an option decayed in a straight line, what we would call a straight line decay, it would do this. We're just going to connect a starting point. We're going to make a straight line all the way down to 0 over 100 days. The average rate of decay is that dotted line. That's how a lot of people think that an option decays. But we can see it clearly doesn't. So, but we're going to use this calculation. The average decay rate is the $10 starting price divided by 100 days.
10 cents.
Equals 10 cents. Now notice, remember that technically what we're measuring is the slope of this angle right here. So notice how the black line is not quite as steep as the red, right? It's a little bit shallower. So I often tell traders to think of this as snow skiers, right? If you're on this mountain right here, you've got less of an angle. You're not going as fast as the guy who's on the dotted line. It's a steeper angle. So we know
the bunny hill up there.
Yeah, we know that on the green line, your theta must be less than 10 cents. Because remember, 10 cents, this angle of this line is exactly 10 cents at each and every point. Down here, kind of looking like it's running parallel to the red line, looks like it's probably close to 10 cents, somewhere in this range. And then down here, we start going off a cliff where we will be more than 10 cents.
Yeah.
So again, another kind of good references. Now, where is this point? So think about this. Here's another little mathematical curiosity for you all to think of. If our slope or our theta is less than 10 cents up here in green, and it's greater than 10 cents down here in red, what do you know has to happen along the way? At some point, it's got to be equal. It can't go from being less to being more without at some point being equal. So the point is, where is that? Well, one thing we can do visually is to take that red line and slide it right out to where it just touches that line. And it turns out, no matter what option factors you're using in time to expiration, volatility, all that stuff, when it has 25% of the time remains, that will equal the average decay. That's a good reference point. So on our little hypothetical option here, I know when 25 days remains, that what are we going to have? We're going to have a theta of 10 cents. All right, so now my theta is going to equal my average, so it's got to equal
up from the initial theta, remember, don't forget, of 5 cents.
Right. So now think about this. Here's why we needed our option pricing. If I come out to today, remember we're assuming that we're starting out here with 100 days to expiration. We know that when there's 25 days, the theta is 10. How much more time is on the clock today compared to 25 days? There's 4 times the amount of time. What does that tell you? That the rate of decay will be half. So our theta is going to be 10 cents divided by the square root of 4.
Square root. It's always the square root.
Because there's 4 times as much time, and that's going to equal 5 cents. So now a good reference point, and you don't have to worry about the square root for this calculation, it's just divide it in half. If you know the 25% mark equals your average, divide that in 2, and that's going to be your current. So I know that my theta up here is 0.5. Anywhere along this, where we have more time than 25%, my theta is less than 10 cents. And any time on this side of the curve, it's got to be greater than 10 cents. And only right at 25%, it will be exactly equal.
And some of you may want to use that as a reference. We get a lot, well, when should I get out of the option if I don't want to get beat up on the theta? Maybe this is a way to help you gauge.
Right. So you can kind of interpolate, even though it's not a straight line. So Stu, what would you guess? If we got 5 cents up here and 10 cents, what's your theta somewhere around in here?
Somewhere in the middle.
Give me a shot.
7.
7 would be a very good guess. 7.5 would be a good guess. Somewhere around 7. Again, in the real world, it's probably not going to be exact because you got lots of things moving.
And again, it doesn't matter.
It doesn't matter, but you've got an idea of how this is going to behave, and you've got an idea of where these numbers are coming from. So,
I remember you came from 5 and we went to 7. Remember what Bill said at the beginning? It's going up.
It's got to go up a little bit each day.
A little bit.
Yep. So here's your steps to find theta. Find your average theta as today's options price divided by days to expiration. Divide that by 2, technically the square root of 4, but it's the same thing. You're going to divide by 2 to find the initial theta. And then you divide the initial theta by the square root of time to find the current theta. All right, so watch this. And yes, it can take some practice, but any good options trader is going to know all of the tricks. It's not going to be easy, but it's something you can certainly do with a little bit of work. So what's the options theta if 50% of the time remains? All right, well, let's go back to our curve. We know that step 1 is what? Average theta is 10 cents. Bang, we got that. Step 2 is what? Divide it by 2, or the square root of 4, is going to be 0.05. So I know that my theta up here today is 0.05. If the question was if 50% of the time remains, what is it there? Well, we have to divide by the square root of time. So I'm going to take the initial theta of 0.05 divided by the square root of 0.5, and that's going to give me 0.07. My theta is going to be 0.07 right there. And I can tell you that. And these are not just kind of rough calculations. Try it in a pricing model. And we'll show you one here in just a moment. So let's do that, Stu. Let's go back to our chalk talk. Let's ask everybody, our $100 call is trading for 4, 90 days to expiration. What's the options theta? Here's the calculations. Average decay is what? Options price divided by 90. Now, if you know your reciprocals, I know that 1/9 is 0.111, so 4/9 would be 0.444. So we know that, 4 divided by 90 would be 0.0444. So that's going to be 0.0444. We divide that by 2. I can tell you the options theta is going to be 0.0222 today, a little over 2 cents. Now, people are going, that can't possibly be true. Let's go put it to the test. Option pricing model, stock is 100, strike is 100, 90 days to expiration, no interest rate. No dividends. I need to make the options volatility 20.2 because that gives us exactly $4, which is what that was just an assumption I made.
Bill's not playing funny money here. He made it 20.2 because he was looking to make it $4.
$4.
For the example, he wanted it to be 4. And that's, hey, you know what? This is kind of a good topic as well. It's a plug-in number, that volatility.
Sure it is.
That's all it is. It's a plug-in number, right? The $4 is what we're looking for. And what is the volatility at $4? 20.
And you can figure that out down here in the implied volatility calculator. We just type in the number we're looking for, $4, and it spits out 20.2. I put 20.2 over here and it comes up with 4. So you can kind of practice with this. Now, what was the answer that we said the theta should be?
7.
0.0222. No, this is for
the second one. Yeah.
This is for the all right,
90 days.
Right. So what happened? There it is. The initial theta must be 0.0222. Okay, and so these are all things that you can kind of do very quickly in your head. Now, hopefully, it's removed some of the mystery where that number is coming from. Average theta is 4 divided by 90. Right, we said that's 1/9 or 0.11 divided by 90 would be 0.0444. We divide that by 2, we get 0.0222. So I know that my initial theta is 0.0222. What's the theta going to be when 50% of the time remains? Take this number, 0.0222, divide it by the square root of 50.
and that will give you the theta. So get in there and practice with it. And if nothing else, at least you have a better idea where these numbers are coming from. So I hope that gives you some help. But these are the things that we really like to teach here at Market Rebellion and with our world-class coaches here, because if you don't know where the numbers are coming from, you're going to be mystified.
You can't figure out where you're going.
You can't figure out where you're going or where you've been.
Yeah.
Right. So any closing comments, Stu?
This is really cool stuff. I mean,
I think so too.
They're easy calculations. There's nothing
very easy
major to memorize, but look, just don't get lost in all this.
No,
right?
Just understand where it's coming from.
You just want to have an idea of what it's going to look like down the road. This is a really easy way to kind of figure it out.
Yep.
Test yourself. Just practice. It doesn't take long. Practice up a little bit. And before you know it, you'll be able to say, hey, in quarter of the time, or if it's a 30-day option halfway through, bang, just like that, you'll be able to come up with something that's in the game.
And if nothing else, if you could at least look at this and say, well, when 25% of the time remains, I know it's going to be 0.0444. And anytime after that, it's going to be greater than 0.0444. Again, all else being equal. So those are some things that all the professional traders know real well, and you can learn to use them yourself to help make better decisions. And that's what we're all about. So I hope you picked up some good tips, and we'll see you next Thursday on Coach's Corner.
Yep. See ya.